Okay, my video is failed to connect. I'm sorry I couldn't use the camera. Okay. Okay, Om Swastiastu, everyone. Good afternoon. Good morning.
Good morning, sir.
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 Morning, sir.
Good morning, sir.
Okay, let's start our meeting today. Today we will talk about operating system. And yesterday I asked you to download two software. The first is the VirtualBox. It is for the virtual machine environment, and then the second file that you have to download is the Ubuntu ISO image. I think maybe some of you already download the files, but if you have not downloaded the required files, it's okay. But I will give you an assignment about that. So in this week, you have to install that program and then run the Ubuntu on top of the VirtualBox, okay? And I will give you some tutorial about how to configure the VirtualBox environments to Ubuntu. The Ubuntu server, Ubuntu version that we use is Ubuntu server. The version is 2004 LTS, I think. And then if you already download the Ubuntu desktop, it's okay also, but the resources will be you will use more resources when you installing the Ubuntu desktop. So I'm preferring you install the Ubuntu server because we will use command line interface, not the graphical user interface. Okay. So okay, before we start our lesson, I will ask you about our assignment. Some of you already post your assignment in the forum. We have 3 forums here: the post your computer specification, and about the GPU, why the GPU has substantially more core compared to CPU, and then the RAM speed and bandwidth. Okay, maybe we will talk about that first before we start our lesson. The first is, I think the computer specification is fairly depend on your computer, and we will not talk about that. And then we will talk about the first question. Why GPU has substantially more core compared to CPU? Do you have any opinion about that? Okay, Kak Ago Kana.
Okay, sir. Thank you for the time. In my opinion, why GPU has more cores than the CPU is because GPU is made to do a specific task such as graphic rendering, so it needs more power. So it gonna has more cores than the CPU because the CPU is used just to make a simple mathematic problem, yeah, like that, sir.
Okay, the GPU are used to calculate a simple mathematic problem, like that. Okay,
No, I mean the CPU is do the simple mathematic problem and the GPU is more specified.
of more specified problem. Okay. Any other student have any opinion? Other opinion about that? Okay, do you have any opinion? Maybe I will ask, okay, Reiki.
Okay, sir. In my opinion, why GPU has many cores than CPU is about because GPU must be must should to render a video or picture that has so many pixels. Then if if the core are low or not many, it's just like lagging. It's like lagging because when in computer we can see a picture with the visualization good and better visualization is that's GPU make it. What I
Okay, when comparing our CPU and GPU, maybe the power is not very different. For
yeah.
example, when the CPU, we need electricity power about 100 watt. Maybe some of GPU CPU require that power. But the GPU is not substantially larger than that. Maybe it need about 150 watts, or in the high end GPU it need maybe over 200 watts, but it's not too different from GPU and CPU. But the cores is very different. For example, the CPU is maybe only 4 or 8 core. Maybe the standard now is 6 or to 8 cores. But when we talk about GPU, the GPU is have very much more core. For example, it's about 1,000 of cores, maybe 2,000, and maybe the high end GPU about 10,000 max GPU core. It's very substantially different. But the power is not very different. Why the GPU needs more core? What's the main purpose of the GPU?
To render a picture.
Yes, to render a picture. What does the specialty of a picture? It is any characteristic of a computer picture that is different from the other data that we use in the computer. For example, when we use text-based data like a Microsoft Word or Notepad, is it different to the picture that we see in the computer? There is any characteristic, any different characteristic about that?
I think the characteristic is like image in video.
Maybe the first generation of GPU is for efficiently rendering a picture. It's not about the video, because when in all the many years before, the video is not common because the computer is not that powerful to rendering a video. So the format of the GPU is using the GPU to render a picture. It's not a video. Why we could render the video or 3D graphic now? Because the GPU is very fast. But in early days of GPU, it's not that fast, but it's specialized for graphic. Okay, to visualize or rendering a two-dimensional picture. So why we need a GPU? That time we have a CPU, we have the central processing unit, and they could render a picture to our screen. But why they invent the GPU? That's why that's the reason. There is a reason to design a GPU, and it is specialized for a graphic. So maybe there is some characteristic, a special characteristic about the picture that we see in the computer. And my question is, what is the characteristic of the picture in the computer?
Pixel, sir.
What is a pixel? What is pixels? I think it's correct because our computer screen is composed by many pixels. For example, full HD resolution. It is, I think, is 190 1920 times 1080 pixel. It's about 2 megapixels. That's called the full HD or 1080p resolution. So we have about 2 megapixel of data for that screen. So my question is, what is a pixel? What is a pixel? Okay, Bagus Muhammad Fajar.
Smallest component on digital pictures.
Smallest component of digital picture. Okay, that's correct. But what the special? What is the uniqueness of the pixel? Because many data that we have is specialized. For example, the text is translated from the ASCII code, and then some other data maybe it's special for their own. But what is special about the pixel? Yes, it is the smallest part of the of our picture in the computer screen or digital screen. But what the special about the what data that represent 1 pixel? What stored data that's stored in the 1 pixel? What data that's stored in 1 pixel? Maybe some of you knew about it. Okay, 1 pixel is stored 3 different data. The first data is red data, color red, and then green and blue. Okay, the range of each color is from 0 to 255 information. Okay, so 1 pixel has 3 colors, red and green and blue, and each color can represent from 0 to 255 different type of different color, different shade of color. Okay, for example, the red is very red until it is the red is off. For the example is there is no red. But when we have the red color is 0, that's the meaning is the red color is not active or 0. And then when we have the 255 of the red, it means the red is very bright, something like that. Then we combine 3 color. So the red and green and blue. That 3 color is combined. So we have about 24 million color Okay, I think 24, or I don't sure about that, but oh sorry, 16 million color. Okay, every color is represent of 8 bit of color, and then when we combine the 3 color, we call that 24-bit color. So our screen is about 24-bit color. Okay, but the highest high and monitor, I think they have 10 color for sorry 10 bit for each color. So when we combine that, is about 30 bit of color. That's the high end monitor, something like that. But our pixel is represented that 3 color. It's about 24 bit of color. Okay, that's the characteristic of our screen, 1 pixel. So the pixel is very simple, because they only have that 3 color. But one screen have so many pixel. For example, 2 megapixel for 1080p screen resolution. That very much very big number of color. And the picture have to render simultaneously. So we have to render all the pixel in one time simultaneously. That's why we need a GPU. Okay, the GPU has more core because we have to render something very very simple, but simultaneously in a big number of pixels. That's why the GPU is invented. When we are using a CPU, that's need some of delay to show our picture. That's why we need a many core in the GPU to render all the picture simultaneously. But the calculation is very simple. So, for example, they only have some of arithmetic logical unit, arithmetic calculation that they could provide. But the CPU is more complex, far more complex than the GPU. It's that's why the CPU called the general purpose processor. But the GPU is specialized purpose of processor. But I think the GPU now is very powerful, that they use to many things other than graphical processing. For example, for machine learning, and then for Bitcoin mining and something like that. But why they use the GPU for that? Because it is for example, the machine learning is very simple calculation actually, but it's need many data to perform the operation, and the GPU is perfect for that. But some of the calculation could not calculate by the GPU. For example, calculating the text, or processing an audio or something like that. That's why we are still using a CPU for that task. Okay, CPU is very fast, very big, but it's not too many. Okay, do you understand about that, about the GPU and CPU core? Do you have any question? Okay, Adi Satya.
Hello, sir. My question is, does GPU have the same thread and the same like CPU, like hyper-thread technology?
Yes, when you talk about the GPU, that they have so many threads, it's many, so many. Maybe in the CPU with hyper-thread technology, we only have 2 threads per core CPU. But When you read about the documentation of the GPU, for example, the NVIDIA GPU, I think they have many more threads per CPU. Oh, sorry, per core compared to the CPU. I think you will have to know about that when you learn about the parallel programming. I think when you want to know about that, learn about parallel programming, because when we talk about parallel programming, we have to know how many threads that we could execute in one processor. And when I learned about the parallel programming and learn about the GPU, as I know, the GPU has more threads than the CPU itself. Maybe because the GPU core is the development of GPU core is very fast, and then they need more threads to calculate our GPU, our graphic. For example, in early days, we only need to render two-dimensional picture, but nowadays we need more dimension. For example, third dimension and something like that to render. That's why they need more threads compared to the CPU. I think something like that, but they don't call it hyperthread because the hyperthread is the trademark of Intel Corporation. Okay, do you have any question? Do I answer your question?
Thank you, sir.
Okay, Reiki, do you have any question?
Sir, why when we play a game with has ultra resolution or high resolution, why GPU works so hard and we need expensive GPU to run at high resolution? Thank you.
It's very simple answer actually. More data need more sources. Simply like that. Okay. Because when we render a larger resolution, we need more data. They need more data to process. So we need more resources to process the data.
So for a better resolution, we need like more expensive GPU to render more speed and highest that data like that?
More resolution mean more data to process. So we need more resources. How we could get the more resources is one thing. Yes, we need to buy more expensive GPU because more expensive GPU means more resources that they provide. Something like that.
Oh, okay, sir, I get it. Thank you.
Yeah. Okay. Next is Bayu. Do you have any question?
I have a question. What if in a computer, CPU and GPU have the same number of the core? It is a problem or not?
What do you think about it?
Can I speak Indonesia?
Yes.
Bagaimana jika di sebuah komputer CPU dan GPU-nya memiliki jumlah core yang sama?
Yes, I understand your question, but what do you think about that? When we have only 4 GPU core for our GPU and then 4 GPU core for our CPU, as your understanding, what devices is faster to render the data? As we talked before, the GPU is very simple. They only calculate some mathematical operation. Compared to CPU, the CPU is very complex. They could process many things. It's not only the mathematical calculation. Maybe the base of the GPU is mathematical calculation, but the ISA, the architecture is very complex that they could automatically or easily do some tasks other than mathematical calculation. That's why the CPU is very complex, but they could process many things of data, many other type of data could be processed by the by the CPU. But the GPU is very simple. But because it's very simple, they need many more processor to do their tasks. Maybe I think one of your forum post is interesting. It's about the you give me one example or one sorry. Okay, this is the analogy by the Melissa Damayanti. I think Melissa is not with us today because she have something to do. Maybe you open the e-learning and read about this. I think it's very interesting. The Melissa answer about this. Okay, the GPU has a lot core. Sorry, this is not Melissa. Yes. They have an analogy. Okay. Like harvesting fruit, and those are run like climbing a mountain. For example, something like this. When you have to climb a mountain, you have to prepare more tools to that you bring to the mountain. Okay, climbing a mountain. For example, you need a rope and you need a big bag to store your belonging, and then you need training to do something to climbing the mountain. So many preparation that you need to climbing a mountain. But when you need to harvesting a fruit, you just need your hand. But how can you harvest your fruit or fruit in a garden, in a big garden, faster? How you harvest the fruit faster? How could you do that? It's very simple task. You just need to pick the fruit, and then that's all you need to do. And you just need your hand, right, to harvest the fruit. But how could you harvest the fruit faster? When you do it yourself, you need a long time, okay? Because you have to pick it one by one by yourself. When the field is very large, you need many time to do that, okay? So how do you propose to harvest the fruit faster? How do you do that?
We need more people, sir.
Yes, we need more people. Do these people need a specialized uh, a specialized thing that they need? For example, like climbing a mountain, we need a rope, we need a big bag, something like that. Do they need something like that? These people to picking a fruit?
I think no, sir,
No,
because
sir,
they need
just
only
use the
hand.
Yes, they only need hand. But how we harvest the fruit faster? We just adding more people to harvest the fruit. But it's very simple problem. Okay, and we need very simple tools to do that. But compared to climbing a mountain, how many people do you think could do that?
Only one, I think it can.
Yes, it's very few people, maybe specialized people to do that, but they need many tools to do that. Okay, and common people could not do that. Could not do that. So they need climbing a mountain. They need a training. They need a specialized tool, something like that. But the climber, could they harvest the fruit? Can the climber harvesting fruit?
Yes,
Of
it can.
Yes, sir,
course,
because
Yes,
they
they
only need
can.
their hand.
slowly.
Yes, because they have hand. They could do that. The CPU could do calculation like the GPU, but they more specialized. They have many tools to do other things rather than only picking a fruit. Only picking a fruit, something like that. That's the analogy. Okay. When we use GPU, it's very simple calculation or a very simple problem that could calculate by the GPU, but they need many people to do that. Okay, many cores to do that. It's like harvesting a fruit. It's very simple, but we need many people to do the operation faster. But when you climbing a mountain, you could not tell these people that harvesting a fruit to climbing a mountain efficiently. They need more time to do that because it's very complex things to do climbing a mountain rather than harvesting a fruit, something like that. So not many people climbing a mountain, but many people could harvesting a fruit, something like that. That's it's a good analogy, I think, by Melissa. Okay. Is it clear? So when the CPU core is when the GPU core is same count like CPU core, yes, the GPU will be very slow because they have to render one by one, render the graphic one by one, and it is need substantially more time. I think that's the reason why the GPU is very much many core in the GPU, something like that. Okay. Do you have any question?
Sir,
Yeah.
so I can conclude that CPU can CPU can does anything, and
Many
GPU
things. I think it's not anything, but many things.
just many things.
Yeah.
Sorry, and GPU has to does on only one thing.
Actually, it's not only one, but it is more simple than CPU.
Oh, more simple.
Yeah, simpler than CPU. The instruction is very simple, but the instruction in CPU is very complex, something like that. Okay, so could we design a CPU that very complex but very many core? Yes, we could, but it will be very expensive. Why we need to do that? Because why we need to do that? Only 4 core is enough. But in GPU, when we are running GPU, we need many core to do that. But it's very simple calculation to do that. So the transistor will be smaller and less complex than the CPU. So we could produce the GPU core many more because it's very simple. Something like that. Okay. Do you have any question? Anyone about the GPU? Okay. Muhammad Fajar.
Excuse me, sir. So can CPU show graphic on monitor with no
Yes.
GPU?
Yes. With no GPU, because in early days it could, because they don't have GPU. But in modern computer, we don't have the CPU don't have that capabilities, because all the operation of graphic processing is directed to GPU. So the CPU doesn't have the capabilities to showing a picture in our monitor, something like that. But in the calculation, the CPU could do that. The calculation, the graphic calculation, it could be done by the CPU. But when the CPU need an output, then need a GPU to do that. But the calculation is doable by the CPU. Maybe you familiar with the game called Crisis. You familiar about that? The Crisis game? It's,
Sir.
I think, yeah, it's a old game, but in my days, when I still in college, I think the Crisis is very GPU demanding. It's very need very large GPU to do the calculation. So the Crisis is very heavy game. But today's, I think some of the developers out there are porting the code of the Crisis game to work well in the CPU without the GPU. I think the Crisis could do that now in the modding modding environment. So when you familiar with the AMD Threadripper, you familiar with that processor, the CPU?
Yes, sir.
Yes, the Threadripper. I think they have the most high-end Threadripper. I think they have 64 core and 128 thread of thread, and then they could run the Crisis game only with the CPU. So the calculation is could be done by the CPU, but the device to translate the pixel signal into the pixel itself could not done by the CPU, because the capabilities is not there. The capabilities of translating the data into the pixel is done by the GPU now. The CPU could not do that. But in early days, it's possible because there is no GPU, and the CPU must do that, something like that. Okay. Do I answer your question?
Yes, sir. Thanks.
Okay, I think this discussion is very interesting. Maybe we go to the next question. Okay, the next question is about the GPU, the memory, the RAM. Okay, what is the relation of PC3 100 12800 compared to 1600 megahertz clock speed, and how you calculate that? Do you have any answer about it? I think do you have any question? Sorry, do you have any answer about it? What is the relation about PC3 12800 compared to 1600 megahertz clock speed? What is this? Okay, Taiki.
Okay, sir, I want to try. PC3 12800 and 16,000. I think it's same name, but like what a different type. PC3 is a type like DDR3. PC3 is DDR3, and 12800 is in megabit per second. So
okay.
Yeah.
So
in to convert megabits to hertz is we need to divide it by 8, because 1 hertz is 8 bits, and then 12800 divided by 8 is 16,000 megahertz.
okay, so I saw your answer here and some of you, but I think 12800 is refer to what? So maybe we will using Excel to do that, to do calculation. Maybe it's simpler. Okay, 1200 is refer to what? Okay, 100 megahertz. It's refer to frequency. Okay, frequency. Okay, or memory frequency. And then 12800 it refers to what?
Memory with that.
I
memory.
think
Yeah, ada Puja?
That is the bandwidth.
Bandwidth, okay. Bandwidth. The memory bandwidth is this is referred to memory bandwidth. And then the unit of frequency is megahertz, okay. So it's or sometimes it's called mega transfer per second, MTS. Yes. Mega transfer per second. Sometimes it's called the megahertz. It's the same thing. Mega transfer per second. Okay. It's or okay. Or megahertz. And the bandwidth. What the unit of the bandwidth?
Megabyte.
Megabyte per second.
Per second.
Yes. The large B, capital B, or lowercase b?
Capital.
If capital is megabyte, and
Yeah.
If apa huruf kecil is a megabit.
So what the bandwidth? Megabyte or megabit in this problem? Bit or byte? Mbps.
Megabyte, I think.
As I read so far, it's megabit.
Okay. What's the correct? The bit or byte?
Byte.
Yes, the correct is byte. Okay, not bits. Okay. The correct answer about the memory bandwidth is byte per second. It's not bit per second. at least for this memory speed, okay, memory bandwidth. So PC3 12800 is referred to DDR3, and the bandwidth is about 12800 megabyte per second, or maybe we could call that 12.8 gigabyte per second. Okay, gigabyte per second, something like that. It's about 12 gigabyte per second. But the calculation is sometimes we are using divided by 1000. Sometimes is divided by 1024. But yes, for now we could tell this about the 12.8 gigabyte per second. Okay, so the unit of the bandwidth here is megabyte per second, is not megabit per second. Okay, and some of your answer is about bits. The bits is about 8 bits, and then the byte is about 1 byte. And when we calculate the frequency, the bandwidth will be the bandwidth will be 1 times 160. So it's about 1600 megabyte per second. When we call the bit is something like this, as Reiki told us before. Okay, but when we are using bits, megabits per second, maybe it's correct. 8 times 1600, will be 12800, but it's megabit per second, not megabyte per second. So I think the answer is not correct. Okay, so how we calculate the frequency into the bandwidth, the correct bandwidth, megabyte per second? How could we calculate this? I think one person have the correct answer in the e-learning. So do you have any answer about this? How we calculate the frequency into the bandwidth, the correct bandwidth? How? You have answer? When you remember when we talk about hardware, especially maybe in GPU, we talk about the core count that we discussed before, and then there are some of the information, for example, the memory type. There is a G in here. It refers to graphic. So graphic, the DDR3, something like that. And then there is a memory speed and then a memory capacity. But some of the information is this, the memory bus. Okay, the memory bus is about, in this GPU, I think it's about 196 bit in the memory bus. The question is, what is a memory bus? Do you familiar about the memory bus? Okay. In DDR or double data rate, the memory bus is 64 bit. Sorry, 64 bits. Okay, it's called a memory bus. It's controlled by the memory controller. So in our CPU, there is a memory controller. That is how to communicate with CPU and the RAM. It's through the memory controller. The memory controller has a memory bus about 64 bits. Okay, in the DDR, I think from DDR to DDR4, it's about 64 bits of memory. 64 bits memory bus. So when we calculate this into the byte, the memory bus is 64, and then when we in bits, and we calculate 64 divided by 8, it's about 8 byte. Okay, the memory bus is about 8 byte, and when we compare this with the frequency, we could calculate this to byte is about 12,800 byte per second. Okay, so why it's 600 megahertz is referred to 12,800 is because the memory bus is 64 bit. Okay, and the memory bus is 64 bit. When we calculate the byte, it's divided by 8, and then we multiply by the frequency, we have the bandwidth, and the bandwidth is about 12,800 megabyte per second. Okay, do you understand about that? The question is, what is memory bus? What the function of memory bus? Okay, the memory bus controlled by memory controller. It's located in the CPU. Okay, the memory controller controls the memory, and the bus width of the memory controller is about 64 bit per channel. Okay. You could imagine something like this. When we have a road, okay, maybe in highway, the highway have many lanes, okay, many lanes. Maybe in one highway, maybe they have 4 lanes. So the car could travel the lanes, travel the road 4 cars at a time, something like that, because they have 4 lanes. Memory bus is like that. So one memory lane represents 1 bit of 1 bits of data that could travel. So when the CPU or the memory have a memory bus of 64 bits, it refers to 64 bit of data could travel at the same time, something like that. So the lanes from the memory to the CPU is 64 bits, something like that. So in one time, the data will be travel 64 bits in one time, something like that. But the frequency is how many data that could travel in 1 second. In this example, is about 1.6 trillion mega is kilo, mega is million, right? So it's about 1,600 million data per second could travel with this frequency. So the bandwidth is how width the lane times how many data that could travel. So the lane is 64. We could multiplied by 1600, and the bandwidth will be 12,800 megabyte per second when we calculate the bytes, something like that. So the memory bus is the lane, the width of the lane. Okay. How many data that could travel in the same time? How many? Something like that. And the frequency is how many data that travel in 1 second. So the calculation will be the bandwidth, something like this. Do you understand about that? Do you have any question? Yes, apa saja?
I'm sorry, sir. Excuse me for the first. Can I ask you to repeat your explanation, but in bahasa?
Okay.
I didn't get it about the.
Okay. Okay, maybe I will talk in bahasa. I'm sorry because it's IKI class. Okay, I will talk in bahasa. Ya, jadi seperti ini. Andaikan ada sebuah jalan, gitu ya, jalan tol. Nah, jalan tol itu kan punya jalurnya, dia punya jalur. Jadi satu jalur, kalau dia hanya ada satu jalur, berarti hanya satu mobil yang dapat lewat di sana, gitu, di jalur tersebut. Tetapi kalau dia punya 64 jalur, berapa mobil bisa lewat dalam waktu yang sama? Berapa mobil?
64
mobil berderetan dia gitu bersama-sama gitu ya. Seperti itu. Lalu frekuensi itu seberapa cepat mobil itu dapat melaju dalam 1 detik. Seperti itu. How fast is the memory or the data will travel in that lane, something like that. Jadi berapa banyak atau seberapa cepat data itu dapat melaju dalam 1 detik. Begitu. Ya, karena ada 64 jalur. Kalau dia hanya ada satu jalur, berarti dia dapat kecepatannya itu atau bandwidth-nya adalah 1600 megabyte per detik. Megabit per detik gitu ya. Tetapi karena sekarang ada 64, jadi 64 dikalikan 1600. Jadi kalau umpamanya kita kalikan 1600 dikali 64 sama dengan 2400. Tetapi karena ini harus dibagi 8 karena dia pakai byte satuannya, dapatlah segini. Gitu. Jadi memory bus itu adalah seberapa lebar jalannya. Seperti itu. Lalu memory frekuensi adalah seberapa cepat mobil itu melaju, seperti itu. Dalam 1 detik. Nah, mungkin kalian bisa bayangkan terkait dengan arus dengan voltase. Arus kali voltase, apa hasilnya? Masih ingat nggak fisika dulu? Volt dikali ampere jadi?
Watt.
Watt itu apa?
Harus
Daya
atau power. Gitu ya. Jadi kita bisa bilang bandwidth itu seperti power lah, seperti itu. Ya. Tetapi arusnya adalah frekuensinya. Seberapa banyak dia dapat, seberapa cepat dia berjalan, itu arusnya. Lalu memory busnya itu adalah voltasenya, seberapa lebarnya. Seperti itu. Nah, jadi pengadaannya seperti itu. Jadi kalau memori itu dia punya DDR ya, paling tidak dia memory bus disebutnya, itu adalah 64 bit. Berarti ada 64 data yang dapat lewat dalam waktu yang sama. Dalam waktu yang sama, jadi itu adalah kata kuncinya, dalam waktu yang sama. Oke? Tetapi kecepatannya atau frekuensinya itu adalah 1600 data yang dapat lewat dalam 1 detik. Seperti itu. Sehingga dia akan dikalikan. Ini dikalikan ini dapat ini. Tapi dalam satuan megabit per second. Nah, kalau dia mencari megabyte tinggal dibagi 8 dapatlah 12.800. Begitu. Dapat dipahami?
Iya, Pak. Terima kasih.
Oke, kalau gitu kita switch lagi ke bahasa Inggris ya. Okay, I think that's the explanation. Maybe it's harder to explain in English because we don't used to talk in English. But it's good for our understanding English better because we have to talk in English. I'm sorry that I don't have many knowledge in English because it's my first time teaching in English actually, especially with you. Okay, do you have any question about the memory bus and memory width? Memory bandwidth and memory frequency. So when you talk about the memory, there is two things that you could write. It is about the bandwidth, something like this, or it's about the memory. Some of the manufacturer they write in their box in bandwidth, sometimes in frequency. It's referring as same time, same thing, but they were written in bandwidth or in frequency, something like that. Okay. That's about the memory. I think one of you that I see, I think this one. Yes. Yes, this is the correct answer. Okay, it's by the Cadet Losinanda Prawira. This is correct because it in bit 64. 64 it's the memory controller. They call that memory bus. But the controller called the memory controller. The memory controller have the memory bus is about 64 bits wide, and then the calculation 2 bytes is divided by 8, so we have 8 bytes, and then we calculate the frequency. The bandwidth by multiplying the memory bus with the frequency. We have the bandwidth. Something like that. Okay, this is the correct answer by Cadet Losinanda Prawira. Okay. Okay, I think that's all about our discussion about hardware. Actually, today we will talk about operating system, but our talk about this assignment is very interesting, so I think it's okay. It is better that we discuss something like this rather than we like other lecture that I talk and you don't say anything. I think it's better than that. But for our lesson today is about operating system. The operating system, we will talk the operating system in detail, in more detail next week, I think. Maybe next week is not a good time because we have an accreditation process for next week. I think some of our lecture will be suspended for next week. Maybe some of our of the teacher will not have their lecture next week. Okay, especially my course. We will not have any lesson next week. Okay. About the operating system, I told you to install VirtualBox. Okay, this is the interface of the VirtualBox, and then we will install the Ubuntu operating system to the VirtualBox, and this is your assignment for this week. Okay. So I will give you some example how to set up the operating system. First, you need to click New button here, and then there is a two mode here: the guided mode and the expert mode. Okay, and we will use the expert mode because we have many options in the expert mode. Okay. And then you write your operating system virtual machine. For example, this called Ubuntu IKI. Call that Ubuntu IKI, and then the folder you could choose your own specific folder, and then we select the type of the operating system. The operating system that we will use is Linux. And then the version or the operating system itself is Ubuntu 64 bits. Okay, and then you set your memory allocation for the virtual machine. Maybe you don't need to allocate the memory too big because the operating system only CLI or command line interface. So we for this example, I just allocate the memory about 2 gigabytes. Okay, 2 gigabytes, and then create a virtual hard disk now. Click create, and then this is the confirmation about the hard disk allocation. I allocate the operating system about 10 gigabyte. When you want, it could more than 10 gigabyte, but I think the minimum requirement is about 10 gigabytes. So I set it to 10 gigabytes, and then leave the other setting, and then click create. Okay. So we have our virtual machine here, Ubuntu IKI. Okay, and then we could click setting to do some of the setting in the operating system or the virtual hardware that we create before. For example, we click the system tab, and then you could resize your memory, something like that. And then the processor, you could allocate how many processors that you use or how many threads that you use for your operating system. For example, I set it to 2 threads CPU for the operating system. And then the important part is about the network. The first network adapter, you choose that called the NAT or network address translation. It is required so your operating system or your virtual machine could access your internet connection. Okay, enable the adapter first, attached to network address translation NAT, and then the second adapter, enable the network adapter, and then you choose the host only adapter. Okay, because it's important because we want to remove your virtual machine from your computer. Okay, so choose host only adapter. Okay, and then okay. So your virtual hardware is ready. Your virtual machine is ready. And then you could press start. And then your computer will be booting, or the virtual machine will be booting. Okay. Choose your operating system. Click this icon, and then click add. And then you choose your ISO image that you have downloaded. Okay, you already download. When you already download the ISO image, choose that. Okay, and then choose the image. Click choose. Sorry, this is a problem. Okay, the boot drive is failing. Okay, when success, they will give you the screen of installation process. Okay, we will install Ubuntu server because we only need command line interface to our lesson next week or in other meeting. Okay, this may take some time because they have to initialize their hardware and then make some setting to initialize your operating system, and something like that. And we have several settings to our operating system. Just wait a moment. The student here familiar with Linux operating system? Who is familiar with Linux operating system here? Have you tried Linux? No?
Debian, sir. I have
Okay.
tried Debian.
Yes, Linux is Debian. Sorry, Ubuntu is Debian, derived from Debian. So maybe the CLI is fairly similar with Debian. Okay. So the first thing you choose your language. I'm using English here. And then this is a keyboard layout. Just click or enter done. This is the network adapter that we choose before when we setting up the virtual box. There is two network adapter here, ENPS S3 and ENPS S8. There is two IP address here. The first is for internet and the second is for communicating with our computer. Okay, and then we choose done. The proxy address is leave it empty. Done. This is the mirror address or the address of the repository application of repository of Ubuntu. Okay, maybe you could imagine this like a Google Play or Play Store, something like that. Okay. In my experience, the ID is from Indonesian server. It's not fast. It's very slow. That's why I'm using the international version server. The server is archive.ubuntu.com/ubuntu. Okay. When you are confident with Indonesian server, leave it alone. It's okay. But as my experience is not good, it's very slow. So I'm using the international server. Okay, and you click done. It is about the hard disk. Just choose done. This is the confirmation of the hard drive. Choose done. Continue. Okay, and then you have to input your name. For example, my name Yudi, and then the server name. I think UD too. UD PC, for example, or UD. And then the username, UD. The password is password. Or whenever you need like to set your password. Okay. And you have to remember the username and the password that you input in this. Okay, we have to log in using the username and password to the Ubuntu. Okay, and then click done. This is one option to install OpenSSH server because we will use SSH to connect our computer to the virtual machine. Okay, just click press space in your keyboard. So they will have X logo in the install OpenSSH server. Okay. And then you choose done. And then this is other application that you could install on your computer or your filter machine, but I don't need this. So just choose done. And then the installation process will be happening. And it need, I think, 30 minutes in my computer. Maybe in some of computer it's faster, and sometimes it's slower. Depend on the hardware in your computer. Okay, and this is your assignment for this week. Okay, you have to install Ubuntu in your virtual machine or in the virtual box. So in next lesson we will try to operate the operating system by CLI or command line interface. We don't need a graphical user interface to operate our virtual machine. Okay. Do you have any question? Yes, Andreas?
Thank you, sir. So can I use another app because my device not supported? So maybe I will use the UTM virtual machine.
Okay, it's okay.
Thank you, sir.
Yes. When you want to install your Ubuntu in your computer, bare metal is okay. When you are using other application other than VirtualBox, it's okay. The requirement is to install the Ubuntu server in your computer. Okay. Do you have any question? Any question? Other student? Okay, about the operating system, we will talk about it in the next lesson. But next week, we will not have lesson because we have to prepare for the accreditation. Okay. I hope the accreditation will be better. And I need your support for the accreditation process. Okay. Maybe some of the students, we will invite some of our students to the accreditation process. We need your help, okay? So thank you for today's lesson. I think the discussion is very interesting, and then I hope that in every lesson or every meeting, we will have interesting discussion. Okay. So this is the end of our lesson today. Thank you everyone for today's meeting. And I close. Okay, Reiki, do you have any question?
How about present? About the absent?
Sir. Oh, sorry. Okay.
The absent.
Use the link that I send you in the chat for the presence attendance. Okay. Use this link every week for our lesson. I will open the attendance list when every time we start our meeting, and then I will close it when the meeting is closed. Okay. So for today, I will give you 15 minutes to fill the attendance list. Okay. Okay. Thank you everyone for this meeting. I will leave the room now. I think the class representation knew how to do the process after our meeting today, because they need to send the video to the IKI operator and then give me the link to upload to the e-learning. Okay. Thank you everyone, and I close this meeting with Paramasanti. Om Santi Santi Santi.
Om Santi Santi Om. Thank you so much, sir.
Thank you so much, sir.
Thank you so much, sir. Thank you, sir.